Good morning, children. Now, this is the application of matrices in solving system of equations. Now, we have three equations in x, y, z. Now, in matrix form, we can write firstly all the coefficients of these three equations in the form of matrix. We say this matrix as coefficient matrix. Now, all the constants d1, d2, d3 can be written in the form of column matrix is called constant matrix, and x, capital X, denotes the three variables x, y, z in the form of column matrix. In matrix form we can write as ax is equal to b. Now clearly we know that we have to find x, y, z for this system. What to do? Pre-multiplying by A inverse on both sides. When we multiply A inverse on both sides, we will get A into A inverse. As I told you in the previous properties, A into A inverse is I. When multiplied by X, matrix X. Now, a matrix when multiplied with I gives same matrix A. Now, it is a property. Now, X will be A inverse B. Now, you can see that in this. Now come to the consistency of the system. What does it mean? It means we can check whether the system having unique solution, infinite many solution, or no solution. What to do for this? First of all, we will find the determinant of A. If the determinant of A is 0, is non-zero, then your matrix A is non-singular. Non-singular means A inverse exists, so we can find directly X is equal to A inverse B, unique solution. Here we have unique solution, or you can say that it is consistent. In the case 2, if your determinant is 0, that is A is a singular matrix, it means A inverse does not exist. When A inverse does not exist, we cannot find A inverse. In this case, what to do? There are two cases arise. Number one, in the first case we will find adjoint A into B. If it appears to be 0, then we have infinitely many solutions. Infinitely many solutions means your system is consistent. On the other hand, if you're getting your adjoint into B non-zero, then the system having no solution. No solution means inconsistent. Before solving a system of equation, we have to check this test of consistency for every system of equation. Now children, come to the problem. Let us consider the first problem. Solve the system of equation using matrix method. In this method, first of all, as you know, we have to write your coefficient matrix, and B is your constant matrix of order 3 by 1, and X is your variable matrix x, y, z. Now in matrix form, all the steps are to be written in the examination. Matrix form is Ax is equal to B. Now first of all, to check inverse, we will find the determinant of this. The value of determinant appears to be 6 which is not equal to 0, it shows that A inverse exists. It means you can write your system of equation in this form: x is equal to A inverse B. Now basically we have to find A inverse for this system. How to find A inverse? As you know, in the previous lecture, we have to find all the cofactors, adjoint and cofactor. As you know, A inverse is equal to adjoint A upon determinant A. We can directly find the adjoint by finding all the cofactors by taking the transpose of cofactors. All the cofactors corresponding to each element are like this. Now whenever you take transpose of it, you will get the inverse of adjoint of this matrix. Finally, to find A inverse, we have to divide this adjoint by 6 because 6 is the value of determinant. Now for finding x, we will use this equation first. From first, x is equal to A inverse B. Now A inverse is to be multiplied with B. This is 3 by 3 matrix and your B is your 6, 2, 1. When you multiply this matrix as row by column, as you know that we will multiply row by column multiplication. On solving, we will get 6, 12 and 18. After dividing each term by 6, we will get 1, 2 and 3. And your x is what? X, Y, Z. By equating both the matrices, we will get x is equal to 1, y is equal to 2, z is equal to 3. This is the solution of system of equation using matrix method. Now children, come to another problem. In this problem we have to find A inverse and hence solve the system of equation. Hence means you have to use this inverse for calculating the system. Now to find inverse, first of all we have to find determinant of this matrix A. When we solve this determinant, we will get 10, which is non-zero. It shows that A inverse exists. In the same way, you have to find adjoint of A by taking transpose of cofactor matrix. Now we have to write all the cofactors. All the cofactors we can calculate in this way. The cofactors are 4, 2, 2, minus 5, 0 and 5, 1, minus 2 and 3. Corresponding to each element we can find the cofactor. By taking its transpose we are getting now to calculate A inverse. As you know that inverse can be calculated by dividing adjoint with its determinant. Now finally we are getting our inverse of the matrix. Now inverse of the matrix, it is to be used for solving the system of equation. Now first of all we have to write coefficient matrix for this. In the matrix form, when we write the coefficient of this, these are 1, 2, 1, minus 1, 1 and 1, 1 minus 3 and 1. Now on observing this system of equation, we have this matrix of coefficients. You can see that the coefficient matrix is just like A, but there is a change in that. It is A, but it is its transpose. Now B is what? B is our constant matrix, that is 4, 0, 2. X is same way as we have done in the previous problem. In matrix form, we can write the system as A dash x is equal to B. X will be A dash inverse into B. As we know that value of the determinant is remains same if we take transpose of a matrix. It is appears to be 10. So A dash inverse is also existing. Now what to do? Here we will use a property related to inverse, as we know that A dash inverse is same as A inverse dash. Now here only we have to do the inverse so obtained in the previous part. We have to take the transpose of this and substitute here. 1 by 10 remains same. Now take the transpose of it. It will be like this. Now we will multiply this by 402. When we multiply this by 402, we will get 18 here, 4 here and 14 here. After dividing by 10, we will get 18 by 10. You can write as 9 by 5. Dividing by 10, y will be 2 by 5 and z will be 14 by 10. You can say that it is 7 by 5. Now you can check the answer is correct or not. Put all the values of x, y, z in this system of equation. You will get the solution. Good morning, children. Now come to the another problem. Matrix A and matrix B, two matrices are given of 3 by 3 order. First of all, we have to find AB, and in this question, using this product AB, we have to solve the system of equation. Now very important thing, you have to learn it. Whenever we are finding the product of AB, we always get product of AB in terms of I. Now it will be occurring in the form of I. What is I? I is the identity matrix. Here in this question, in this product, whenever you multiply this by this by this and this by this, we always get identity matrix here, but the number which are lying here, it may change, like it may be 2 2 2, it may be 3 3 3, it may be 4 4 4. It will be in the form of product of I. Now in this way we are getting this AB as I. Now AB is I. Now first of all we have to write the whole coefficients of this system of equation. Now I'm going to write coefficient of x is 1, y is absent, it is 0, z is 3, minus 1, 2 and minus 2, 2 minus 3, 4. Now you can see this matrix is 1 0 3 minus 1 2 minus 2 2 minus 3 and 4. Now you can see you can observe this matrix A. This is A transpose. Now this matrix is in terms of A transpose. Now this is your coefficient matrix. Now in the same way we can write our matrix C, because B is already given here. Now we will consider as C. It is your constant matrix and X is your variable matrix. Now your matrix form will be A dash X is equal to C. Now we want X. What to do? We will pre-multiply by A dash inverse on both sides. We will get X is equal to this. Now we have to find A inverse in this case, because we know that A dash inverse is same as A inverse dash. Now in this way we can find X from here. Now we want A inverse. Now using this product AB, we can find A inverse from here, pre-multiplying both sides by A inverse. Whenever we multiply by A inverse, it becomes I. It is A inverse. It means your B gives A inverse. Now we can write here in place of A inverse B. It is B dash. Now what is B dash? B is given we have to take the transpose of it, and it is to be multiplied with C. C is your constant matrix. Whenever you multiply this, we will get 0, 5 and 3. This is your x, y, z. Now on equating, we will get x is equal to 0, y is equal to 5, z is equal to 3. That's all.